Alright, everybody. Slowly but steadily, I'm getting going here. Things are just slightly off kilter, as they always seem to be first thing in the day. For example, my face, it's flying around. Let's see here. I'm not going to use that view, because obviously it's not frickin' working. Alright, today is session 8, I think it is. Actually, let's look at the previous ones real quick. YouTube. And we'll look at, how do you thrashing code. There's thrashing code. Geez, I have 61 videos, I think. So the last Go episode, I guess, was 6, so we're on 7. And this one was largely around interfaces, right? Yeah, I think so. Yes, I am a Go developer. And yeah, I guess we're rare in the wild. We're not rare in the Northwest, in Seattle, or in San Francisco, or Portland. But I guess overall we are. More commonly one sees the JavaScript, or the C#.net, or the Java developer out in the wild. So yeah, alright, last episode we got into interfaces. That became an interesting conversation. Interfaces are definitely different in Go than in a lot of the languages of those that I just referred to, like C# and Java. They have class interfaces. Go has function interfaces. So kind of a different boat there. Today we're going to dive into and look at some Go routines, though. And it's going to be a little rough because I don't have my book that I like to work from today. I don't know what I did with it. I think it's either on a bus or it's at my other office. So we're going to look at Go routines, which work similarly to, like, if you know what threads are, kind of like that. It helps you shoot off different different actions that run simultaneously in an asynchronous way. This little, can I not? Pull this up here. We'll take this and we're going to actually just run it. But we're not even going to run it here. What we're going to do is put it in our local IDE. So we get Golang running here. Oh. Well, there we go. Finally figured out the problem with my other crazy window here. Sort of. There we go. Okay, fix that. Just in case I need this screen. Using the XPS, I have the great nose shot, the up the nose shot camera angle here for everybody to enjoy. But more importantly, we're going to bounce back into the IDE here. Take a look at this thing. Alright, that's Learning Go episode 6. We're going to make a new one like we always do here. And we're going to call it Learning Go episode 7. Could have sworn we did 7, but that's because I missed last week. That kind of sucked. Internet problems, computer problems, all sorts of stuff I goofed up. I was feeling crappy too, so I just had to call it a day and just not stream. Not even talk. I think I just sat and stared at some stuff. Every once in a while it's good to do that kind of thing. So I'm going to create a simple application here in Golang, and then that code that I just copied, I'm just going to paste it in. Oops. All right. If anybody has thoughts, questions, etc. as we work through all this stuff, please let me know. I'm happy to stop and discuss anything that I'm showing you or that I'm trying to figure out. And like I was saying, we're working on Go routines today. As I tell you this, I'm bringing up a little bit of tunes that hopefully I got something. Speaking of things, where I can kind of control the volume autonomously of the overall machine. So like most audio players don't have a, or not most, some, like the default Ubuntu one doesn't have an audio that's autonomous of the machine. So if I turn the radio down or the music down, I turn down everything, me talking and everything. So that kind of sucked. And I had to get something different. So I have this thing called Audacious, and it enables me to control that volume, which is perfect. Oops. All right, so first thing we're going to tackle here is running this code that just download here, or just copied, and really download anything. We're going to do a go build, set package. Let's say run build. Let's say called build some Go routines. Nothing really to pass into it, and then run that. Boom. There's our Nyan cat hauling ass, and voila, results. So direct 0, direct 1, direct 2. So we know it builds. Let's take a look at what we're doing though. So in this shindig, we have our main func here, which is calling various actions. And we also have this f func, which has a for loop, steps through 3 times, and says print from something I. Basically the point it's counting through that for loop, right? So then we look down here, and what are we actually doing? So we call it, we pass it direct. So from string, do this stuff. Suppose we have a function called fs. Here's how we'd call it in the usual way, running it synchronously. Okay, that's a good point. That is a synchronous call. It means it will execute, and when it's done executing, it will do the next thing below that command, or the next command there. So like if I said format.println, print line, the call is complete, and if I put one before it, like this, format.println, said the call is executing next, these would always run in that order, right? So like if I run that, you'll see the call is executing next, and the call is complete, right? So f runs 3 times. Direct 0, direct 1, direct 2. Then here, to invoke this function in a Go routine, use go f call the thing. This new Go routine will execute concurrently with the calling one. You can also start a Go routine from an anonymous function call like this. Now, okay, so that anonymous function goes out and calls and passes in going into the func, right? Oh, into the func that it's creating. Okay, so this is asynchronous, and this is asynchronous, but this call is not. This call we get to see in the thing. Synchronous and separate Go routines now, so execution falls through to here. This scan line requires to press a key before the program exits. I see what they're trying to do. So they're trying to have this code run. I can't run it this way. This build doesn't work for this. I have to do the terminal to get this to actually run the way they're trying to set up the example to show us. So let's actually do a go build. now we should have our executable. We do. And let's run learning go 7. Now this is going to look very different, because if we look back here, we have that the call is executing, and then it executes those 3 calls. But while that's occurring, and since we have a wait down here for the print button to be pressed, or the any key, whatever, not the print button, these things will execute and print out also, right? So we'll see the go routine executing, and we'll see the anonymous function call executing both of those asynchronously, and printing out in an order that we don't particularly know how they'll print out just yet. So let's execute that. There we go. So now it's waiting. That's why the cursor's blinking there and there, down there. So I'll hit enter. Whoops, not that. Enter. There we go. So let's look at the output now. What did we get? The call is executing. The call is complete. Those are the things that I put in there just to show that that F call to that call to the function F is happening synchronously. If the call is executing next, call is complete, and then direct 0, 1, and 2. That's the for loop going through. Now, because we wait, the things that happen that are being called out to the go routines are happening after that, and currently it looks like they're happening in pretty quick order, because there's no waits, they're not like queuing for an HTTP request or something like that would take time, but they could come back out of sequence versus what is written in the code. So here we have go to routine 0, 1, and 2 running, and then going running, which is the anonymous function here, right? And those call out in what appears to be, at first glance, synchronous because it's in order. But those two are not actually being executed synchronously. Let's look up and prove that out, right? So let's look at golang wait. Just wait. Let's see if there's a wait. How to wait for all routines to execute. Oh, Nathan. Hey, Nathan. What's up? The hacky way. Yeah, let's look at the hacky way. Yeah, time.sleep. That's the command I wanted. Let's put that in there. We'll get some waits, and we'll see. There we go. So now I'm going to actually call this. We'll do this. Say go F. Start some other go routines. We'll call this one go routine 1, 2, and 3. Sally is working. Frank is working. And what is Adrian doing? So this is going to show this happening in a kind of weird ordered way. So let's run that, and you'll get to see each of these routines will be launched off, and it'll go down here and execute this one. I'm pointing like you can see me point. So you'll see these launch off and execute, and this one, but then every, what is it, we got second times 3, so every 3 seconds these will be executing the second part of the for loop, the third part of the for loop, etc. I'm going to actually, let's see, let's do, oh, I know what. Let's add pause, make it a bool. We'll say if pause, do this thing. Oops, there we go. So here, I want no pause, because I just wanted to get going and get done. But these, I do want the pauses. Okay. But then on this one, let's just say false. Sally will get done really quick. Now let's run that. Oh, of course I can't run it there because that just, like, I guess throws in an enter or whatever to it, so you can't really use that one. So let's build. Boom. See, now as the 3 seconds pass, you see subsequent executions going. You see which one started first. The second go routine is now executing. So we have go routine 2, Frank is working, and go routine 1 is actually executing afterwards, because 1 started its countdown, its 3-second countdown before, whereas Frank started right afterwards. So that means Frank would then pop up before on the next subsequent execution, etc. Now the interesting thing here to me is, okay, so here's Sally got all of her work done, but then Frank is still putting along here, and then Frank gets 2 done, and then and what am I doing, right? What is Adrian doing? So there we actually can see that this stuff is happening asynchronously, right? It's not waiting for other things to happen. It's just initiating, and then the count is occurring, and then boom, the results are getting printed out as it goes. So going also executed there. So we're really, all we have to do now is hit enter because everything is done executing. There we go, done. So that gives us a quick view into basic Go routines, where you're just launching off some stuff, shooting it off to wherever, and making that happen. One of the things that I used this for a while ago was, let's see if I can find this. I think it's still out there. Let's see, Adrian, my repos. Do I have this stuff? I have some sample of putting data into Elasticsearch and also putting data into Honeycomb. And I was just doing some tests where I was using hundreds of Go routines. It would loop through in a loop, launch off hundreds of Go routines, and write all this data. So I was doing that to see what the fastest way would be to get data into the whatever I was putting it into, Elasticsearch or Honeycomb. Oh, here it is. Is this it, I think, maybe? These are my, yeah. Oh, that's from Honeycomb. That's their Go library. It's a good one. Check it out if you want to. Honeyvent, not sure what that is. So yeah, this library should be. Yep. So I was just going through with the init and writing data to Honeycomb with the libhoneycomb key. So if we go look at my main, you can see where I was count of items to write per routine and the number of Go routines. So I was just using 10 there. I would loop through and then write in all this data using using a map with string interface. So this is my record that I was writing. It's a pretty big one, and it's basically like a kind of a mock HA proxy, hot proxy record, kind of a thing that you would see in a log file, so that I could get high cardinality log files written into Honeycomb and then query based off of that in Honeycomb. So that's another quick sample. It uses the Faker library, which I believe we used in the first or second or third session of this Go Learning series. Or maybe I used it, I don't know. I showed it in the past. It's a pretty cool little library by DMGK, just called Faker. It just puts fake data in there. The cool thing though is it has like IPs and other stuff that it'll add into the library. Alright, so this is an interesting way to do it. Messages, Go Func. So here, let's talk about this code that Nathan here has been building. So Nathan, let's see here. Yep, he's still at Honeycomb. Cool. I met him at Honeycomb. Nathan's a cool fella. We had a good time working on things. Let's see, finish executing before continuing. So it looks like what he's got going on here, so he's making a channel here called make channel int messages go func, go func, go func, go func. So using the delegate, I keep calling it that. That's delegating in C# when you write a anonymous function like that and tell it to run the function. So he's basically setting up a channel to communicate and then saying sleep, time.sleep, time.second, so 3 seconds, 2 seconds, 1 second, and then passing a message into that channel of 1, 2, 3, for I range messages, time.sleep, time, second, 3, 2, 1. So then he's got another one going on here for I equals done in a canonical way. We have to just go through this one. This is good material. This is a really good blog entry. So what do y'all think? You want to go through this one? Let me dig up another example and go through it. Making the command decision. We're going to go through that one. So we're going to use Nathan's example and write some more code. First, let's do standard practice here. Clear, get checkout, new branch. We'll just call this basic go routine example. Oh, whoops, get init. Now let's do it. Oh, actually, get add everything. Oh, I did not want to do that. Yes, create get ignore. Oh, that's cool. Use templates, learning stuff about Golang. This is cool. A, B, C, D, E, F, G. There's our golib. Perfect. So generate that get ignore. Add it. If you choose cancel, yeah, I want to add it now. And then also let's add our .ida directory. And get. Stop doing that. Get. Can I not type in the thing anymore? Oh, I'm over here. That's why. Let's use this and get all that stuff added. We're going to take IDEA out. My stuff. First commit for episode 7. We'll commit that. Commit. Alright. So then, let's do it. I still can't type in that. That's really weird. Huh, I'll type in this one. Status. Alright, we got all that IDE stuff. But, oh shoot, this is going to break the IDE, probably. So I'm add the deletion because I don't actually want that in there. Clean up, boom, get, push, oh wait, get status, where are we at now? Okay, clear. And then get remote, add origin, let's get that done. So I'm opening up Firefox because I'm already authenticated with Firefox. And then get into GitHub and we'll go ahead and add this. Oh, I guess I'm not authenticated with Firefox. Alright, bear with me here. Gotta authenticate real quick. Two-factor authentication always takes like 5 minutes longer. Almost done. And boom. Alright, now I'm back. Authenticated and creating a new repo. So learning Go, learning Go episode 7. The Go routine episode. And we're not going to initialize it because we like to do those things. And there's our repo path. Adding it here. What? Paste. There we go. Adding that. Now we have our remote repo, and we can git push, map it, origin to master, and boom. All right. So now, I did that, I want to do this. Clear, that's clear, so now we can get branch, check out, new branch, and we'll call it Go routine. Oh, it was basic, right? Yeah, that's what I want to do. Basic, Go routine examples. And then I'm going to do another one, get checkout, be Go routine channel examples. And so get status. Yep, okay, so go push. Let's put this one up for the examples we already have, that we did. Oh, whoops. Okay, push origin. There we go. And then we want to do get push origin, our current one, which is Go routine channel examples. There we go. All the example paths and stuff are now pushed. Clear and exit that. And with that, we are going to clean up this file real quick to put some new code in here around actually doing what Nathan had set up. Refresh that. There we go. Cool. Alright, so let's look at what he's got here. So, pointed out by a lot of information in this article is dangerously inaccurate. Oh, whoops, maybe. A follow-up article here for reviewing pleasure, but I'm leaving this article for historical purposes. Let's take a look at that then. Main Go routine and the printing Go routine race against each other. It's often the case main Go routine will win. Here I will rewrite some of the example so there's synchronization around the printing steps so that the programs behave reliably all the time. What was wrong? Effin pointed out in the previous example, there are a variety of issues with the examples. It's a done channel to communicate the status of the routines. Yeah, and it turns out that this was completely unnecessary. This is the original code. So yeah, that's the first one we looked at. So he's got done, which is making a channel. And then he posts that stuff into here. And then, weird, okay, think about it. Effin's assertion that the channel is unneeded makes a lot of sense. Since you know the number of messages ahead of time, it's a great example of how you shouldn't needlessly overcomplicate things. So yeah, right here, he writes the simple one. So let's put that in our compiler and mess with it. So here, we have the first one running. and it passes in message 1, and then the second one and the third one. So for the 3, basically, print out the messages, and whatever, and that should just do it in order, right? 3, 2, 1, boom, and it counts it down, basically, right? Interesting. So yeah, and since it's timed, we have 3 second, 2 second, 1 second counter. So, oh yeah, and it's messaging. So yeah, like if I actually pass the right message, it's 3, 2, 1, then it'll count it in order, right? Because this one's going to run in just 1 second, and so even though this one's initiated first, then this one's initiated second, and this one's initiated third, because it's going to run through the code in that order, this one has a 3 second counter, 2 second counter, and 1 second counter. And since this is effectively all occurring at one time because of Go routines, that means that we'll get the countdown like we see. Because really, 1 second is going to be so dramatically less in countdown for a computer like this than 2 and 3 seconds would. So obviously we get a countdown of 1, 2, 3. That's kind of an interesting example. Let's see here. All right, what was wrong with the canonical way? Okay, that's the old school way. Well, for one thing, the messages channel doesn't get closed. Oh. It's also not exactly considered the best use for a wait group, as NF put it. It blocks trying to receive a 4th message that never comes. This will create a memory leak in a long-running program. Yes, it would. The need to close the messages channel after the wg.wait to make sure the Go routine terminates. Obviously not a problem in a trivial program, but we should teach good practices at all times. But that still doesn't solve the problem of the racing and printing Go routines, and there's no reason why the so-called old school way isn't appropriate here. When you know the number of messages to expect, you might as well count them to know when to finish. Here the wait group is superfluous and confusing. Wait groups are more useful for doing different tasks in parallel. More importantly, Nathan says he mistakenly put the code to print the results in its own Go routine, which causes a race condition between the main Go routine and the Go routine that is printing. In many cases, the main Go routine will win this race, which is bad. Turns out that my whole sleep for a few seconds, then send a message down the channel example is actually not a good example for wait groups at all. Okay, well, we'll skip that one then. Conclusion. All I know is that I know nothing at all. That's funny. But cool, it's always good to learn, even when one is fumbling through some mistakes or whatnot. So, props to Nathan. Good job on the learning. Let's see here, channels. Golang channels. Let's look directly at some docs here. Tour of Go, and then whoops, I want to go all of the stuff there. There we go. So, talking about channels, as you can see here in this example, bounce that over here and then get that in here. Got a couple of things going on here. We got some. Let's read through this and figure it out. One thing I want to start doing in these sessions is actually reading through code from on the internet, because seriously, it's an important skill. It's a very important skill to be able to read code. Most of what we have out there in the world is I don't know. There's a lot of stuff that's just already written. There's a lot of stuff that doesn't need rewritten. If you're using open source code, then you got a shit ton of code that's already written, that's available for you. There's no reason for you to go reinvent something. Get rid of the NIH, not invented here syndrome, and use other people's code. It's there for use. It's there to help you learn. It's there to help you get the job done on a daily basis. But also, one doesn't need to just assume all the time that all code you see works. As Nathan's blog entry points out, like his first stab at that was off kilter. It had some incorrect information, and he went back and corrected a lot of it. We're always learning, So make sure that you know, learn how to read code. Get good at reading code. Get as good at reading code as writing algorithms or any of that other crap. Because seriously, we shouldn't just be reinventing the wheel every day, which is a lot of what happens in industry, reinventing that wheel and this wheel and whatever. And it's crap. It's not a good idea to do that. We don't need to. It's more work than we need to do. You know, you can get the job done faster if you're good at reading code. So anyway, enough of that rant. Let's read this code and figure out what's going on here. So we got two functs. We got a main, which we always have to have, right? And then we got a sum in this example. So here we have an int array being passed in, and then a channel, which is just getting an int value channel to get passed in. But let's back up just a little bit. A good thing to read here in this example. Channels are a typed conduit through which you can send and receive values with the channel operator. Okay, so the channel operator, from my understanding, is whatever is initiating the Go routine that the channel is going to be used to communicate with, etc. And the channel is available throughout the various routines, and you can pass information back and forth to the main executing program, and be able to take actions on that to, like, kill a routine or know when it's done or whatever. Those types of things that you would need to know when things are occurring asynchronously. If you're familiar with JavaScript, you've probably heard of promises. Same type of thing, right? Where the promise is just executing, or is waiting for some execution. You're looking for the promise to be completed so that you can then take some other action, or at least know something is done. All right, so, and being a typed conduit means that when you create a channel, you generally create a channel to take an int, or in some cases you may have a string passed in or something like that. Whatever you need to be able to pass information back and forth that's pertinent to making decisions about whatever's occurring within that channel and the routines. Good addendums here is the data flows in the direction of the arrow here. So whenever we when we put data into the channel, one, it has to be the type of what the channel is created, right? So if it's an int channel, you need to pass int values into it. You can't pass strings or an arbitrary array or something like that. So that's the first thing. And in this case, like if you look over here, you see channel, arrow left, v. That sends the value v, which again would be an int, most likely in our case, right? Because we've declared an int, into that channel. If it's not an int, it's just going to do a type error when you try to build, and you have to fix it. And then below that is getting the value out of the channel, because you have to get it out of the channel at some point if you want to work with it, right? So that receives it from the channel and then assigns it to the value of v. And a little bit loaded here. You can just you have this is equal to, which means you're creating this variable and assigning it a value, which is getting basically pumped out of or received from the channel ch, right? When you create a channel, you're going to create it through using the make syntax right there. And then the other little addendums here. By default, sends and receives block until the other side is ready. This allows Go routines to synchronize without explicit locks or condition variables. It's important to note too. All right, so let's look more at this code now that we backed up and covered what the heck a channel is in the first place, right? Updates. Why are you giving me updates in the middle of me doing something? Get out of here. All right, so we have func main, and right here, s is getting assigned to the value, or is being created as an int array with these 6 values: 7, 2, 8, -9, 4, and 0. Then we create a channel of type int, and then we do sum here. So it's sum s, so that array, length s divided by 2, and then c. So we are giving the sum a channel. So up here we are passing it the int array, and then here we pass in the channel. So then it says sum is equal to 0, and then 4, again skipping the error, possible error, and just act on the data. So v is equal to the range of s. So then we step through with v here, and then we execute, or no wait, yeah, C channel, and pass the sum of this into the channel. So this routine is being executed, and then this go routine is being executed, and then we receive from C, C being the channel, right, into X and Y, and then we print X and Y and then X plus Y. Whew, that's a lot of meandering and kind of going through the flow there. Alright, so let's just move my window. There it is. Let's execute that and see what we get. 5, 17, and 12. So that's addition of all that, then divided by 2. So that's 10, and then divided by 2. This is 17. Alright, and then pass into the channel. Interesting. I don't really like this example that much, but it does show Go routines being executed. I call in the function here. So Go routines are being used to execute sum, and then there's the channel to communicate in and out of. But it's really just pumping information into it so that you can sum, pass into C. Interesting. So then X and Y is that channel. That is weird. So basically that is the first one. Yeah, not super clear exactly what's going on at first glance. But you can see length 5 divided by 2. Let's see. Huh. Yeah, I don't really like that one. But let's put it in here as an example. Clear, and then, oops, clear. What's our channel? Is Go routine channel samples. Okay. I don't really want that. Example of Go routines and channel use. And got to give it credit, right? Or give the page credit. Oh, I didn't. Cool. Did not need to close that, darn it. There we go. And let's put in a reference to that page. Is this the one I just got? No. It's the one I'm about to look at. Oh, well, we ain't got to put it in there right now. There we go. Alright, let's take a look at this simpler example. This looks like it might be a little bit easier to dork around with and really figure out what's going on. Alright, so what do we have here? Right, channels are the pipes that connect concurrent Go routines. You can send values into the channels from one Go routine and receive those values into another Go routine. Alright, let's also do this. And we'll get that URL for reference this time. Example from that location. Alright, so we have a message. We make it, and we're doing a string value this time. And then we have an anonymous function that passes ping into the function. And then in the message we ask to return whatever's in the channel, the message in the channel, and we should get ping, right? That's pretty straightforward. Let's run that. Ping. There we go, just as expected. Send a value into the channel. Syntax here, we sing ping to the messages channel we made above from a new Go routine. So this could be executing, doing stuff, and we could still ask for that. Let's do, elaborate on this just so we can see what's up here. So after that, I'm going to put a time dot what is it again? Count, slice, since. Damn it. Oh, time wait. Right? No, I don't want to count time. I want to Golang wait. What was the syntax I just used? 5 seconds ago I got this. No, just Nathan's post again. I was asleep, that's what it is. So wait 3 seconds. Message. Let's do something gnarly and just do this. So this occurred, right? So in here, terminal, clear, status, Go routine channel examples. Copy that real quick. A scan line, that's what I was trying to think of. Yes, I just went about that in a very roundabout way. There we go. All right. So now we can wait and see what's going to happen here. So we got ping. And if I'm correct, we should get ping, and then this should print out subsequently after this. And then we should be able to wait, and then that should occur. So let's see what happens. Oh, of course I can't do it this way. Go build, and then learning, there we go, ping. So this occurred, yep. And then I can do done. All right, so that gives you an idea that this is still executing. You put a thing into the message, and then after all this happens, let's do messages like this, and actually do we had our anonymous function complete. So we'll remove that, put that at 2 just for good measure, and then here instead of done, we're going to put the message in again. Okay, so let's see what we get here. Same mistake. Oops. Build, run it, there's ping, and then now that new value should be passed into the messages channel. So let's hit enter and see what we get. So we still have ping. We need to update our message with what is in the latest messages channel, right? unhandled error. Oh, yeah, whatever. So let's build that. And then now you can see ping, and then that should be placed into the messages now. So if I ask to receive what the messages are, whatever, now we had our anonymous function complete. So you can see how that just changes the active message in the channel, so you can see what's going on there, right? And you can ask for that whenever during the execution of the Go routine here. So like if we added, let's just do some crazy stuff. 2, and let's just say messages. Say 8, 9, 10 seconds. This is 8 seconds, 6 seconds, 4 seconds, right? So now, depending on when we press the button, we get different results, right? So let's say 1, 2, 3, 4, 5, 6. Boom. Oh. No? Let's see if we wait around for a few seconds. What happens? Maybe I had not given it enough time to figure that out. No, it looks like the other ones are not. We're not getting to these. Interesting. So that was a poor example on my behalf. So scan line. Any thoughts on why that might be? Messages. That's messaging. Ping message we sent above and printed out. Right. Let's add some comments here. Here, time has elapsed, and the messages channel has a new value in it. And we ask to receive the latest message and print it out. So build that, and that still occurs as we expect. Ping, and then if I hit enter, we had our anonymous function complete. So let's look at the next bit here. So we could run channel buffering. By default, channels are unbuffered, meaning that they will only accept sends if there is a corresponding run it again as is, please. Oh, let me back up. I'm going to go back in my time machine here. This one as is, or would I had the other stuff in there, Dave? I already deleted it out of my copy paste queue. Oops. Channels are, oh, this sentence here. By default, channels are unbuffered, meaning that they will only accept sends if there is a corresponding receive, ready to receive the sent value. Ah, genius. Yes, I see what you're saying. Yeah. So that's something I just learned. But it completely makes sense for Go, since basically you have to have everything assigned, and it has to be able to build knowing what things are assigned, what types, and what it's doing with values. You can't just randomly send in unused stuff. So that's pretty cool. You generally can't send in unused stuff. You can declare a bunch of stuff in other files. There's ways to do it, but generally speaking, it kind of protects you from assigning something that you never end up using. That's pretty cool. Right. Cool. Good catch. Yeah, I was just not sure. I had missed your initial message when you put that in there, so I wasn't sure what you were referring to time-wise. So let's hear. This one is buffer channel. So that's basically what I just went through. So we're going to skip this one. Bounce into channel synchronization. So let's save this. Let's hear. And don't want to save the binary. So save that. Sample code routines and channel use plus learning unbuffered messaging. Commit, please. Alright, and now we're going to do another git check out a new branch, and we'll call it channel synchronization example. There we go. Clear. Let's knock this out of here. We'll just paste this example in. Builds and runs, says done. Alright, time to read some code again. So in this one, use channels to synchronize execution across Go routines. Here's an example of using a blocking receive to wait for a Go routine to finish. So here, we print synchronously working, synchronously in the function, that is. And then we wait 1 second before it's done. We send a value to notify that we're done. Done equals true. So here, make channel bool 1. Start a worker routine, giving it the channel to notify on. Right, block until we receive notification from the worker on the channel. Oh, that is trippy. Okay. Working and then done. If I go build, let's see what we get. Working, done. Ah, very nice. So that's just waiting for the work to be done, which in this case is just time.sleep. Let's do this. Make it more obvious that it's occurring. I'm trying to see. Is this just not? Oh, it does do it. So to note, if we block like this appropriately, where we're waiting for done, okay, then we can use Golang to actually build, because it will wait for a blocking Go routine to finish and show us the results, as we see here, working, done. Whereas the other way to do it, like if you're just waiting for someone to hit enter or whatever, it'll execute all that and just skip right out of it. It doesn't wait for terminal input via this build command, largely because the IDE can't wait for terminal input like that. You need to execute it from the terminal if you have terminal input. Or we can go in to edit configurations and we can add environment variables or other programs to run in lieu of terminal input. So there is ways to do it, but otherwise, if you want to have terminal input, you need to execute it from the terminal. Alright, let's see here. Ghost synchronization was nice. Channel directions, though. Alright. Now we get into some pings and pongs here. Let's get that committed. Boom. Example of channel synchronization. Yeah, I feel like this light rock song popped into my queue without my permission. Bear with me, I gotta do something before this song puts me to sleep here. Here we go. Do this. No. Oh, my stupid music app doesn't sort my music. Okay. Oh. There we go. The difficulties of computer programs. Alright, so this one's going in. No changes detected. Correct. So let's do another get checkout new branch. We're going to call this one channel directions. Oops, clear, and put that one in. And back to reading code. What do we got here? So this ping function only accepts the channel for sending values. It would be a compile time error to try to receive on this channel. Channel for sending. Oh, okay, so it only sends values. So it's pumping data out, but won't receive data. So that's interesting. So that's the ping. So we can think of that as like our client sending a ping, right? And then Pong accepts one channel for receives from the pings, and a second for sends, pongs. So if it gets a ping, theoretically it will pong, right? So then our main, we have pings is equal to this channel, and then we have pongs equal to this channel. And then, so pass message, ping, and then pong. Alright, so we're going to ping, pass the message. That's kind of weird. Format. So you can send in. So we make this channel here. Oh, okay, yeah. So you pass in the channel. It's gonna send stuff. Let's see about that. Yeah, I think we're gonna have to execute this from here. Go build. And we'll execute this. Pass message. Ping. Okay, so that's interesting functionality. Function accepts one channel, receives pings, and a second for pongs. So let's look back at here, back at the page. This ping function accepts the pongs. Okay, well that's what it said, and the other thing. So what exactly are they trying to show here? When using channels as function parameters, you can specify if a channel is meant only to receive values. This specificity increases the type safety program. Okay, channel directions, I get what they're trying to show. They're just showing this. It doesn't really print out much of anything then. Let's us do that. So we'll print out pongs here. Right? Is that what we're asking for? Yeah, which is pass message goes into ping, goes into pings here, and then pong, pings and pongs. So you pass in that message channel, which has pass message in it, and you have pong. So then pings is passed into the message, and then message is passed into pong. So this is just this is it's freaking football, right? You're passing in a message from one function, then that second function takes that message from the first function, passes it into a variable, message, MSG, and then Pongs receives the message from that first channel, hands it back out as Pongs here. That's almost confusing because there's not really an elaboration to see what's happening during different points here of the state. We're literally passing it in, it's going through this one. So like here, we would have additional processing of some sort. Woohoo! Okay. And maybe some initial something happening with the ping, right? And then returning that. But because we just pass this in, we don't really get to see what's happening here. It's almost like it's like a convoluted Hello World application is what this is. But I'm going to save that in there. I'll be sure to put that in the blog entry in a definitive way, outlining that. So it's here, and then we got select. Those select lets you wait on multiple channel operations. So this is even more like the promises than what I was trying to do earlier. Try sending to pings from within Pong. Try sending to pings from within Pong. Try sending to pings. Oh, like this. Just to break it. Well, it just, yeah, can't do that. So that's good example, but better example when we write out some code that's just going to break to show how it takes a channel that will only send, not receive. Or you can't, what's the word? Yeah. So try to send things within the Pong. So the compiler won't even let us do that, which is cool. What's here? Pings to message to Pongs. I don't know. Can't think of any trippy stuff to do right there to kind of add exemplification to it. The select example next here is pretty cool. Oh, and then timeouts. Let's go through these non-blocking channel operations. That almost sounds like Node.js. Woohoo! Alright, so the select lets you wait on multiple channel operations. Combining Go routines and channels with select is a powerful feature of Go. This example, we're going to do 2 channels. Alright, let's grab the code here and look at it in our IDE. Alright, and then let's see here. Okay, checkout. Katuka, thanks for the follow. Welcome to the mosh pit. Lost my machine again. Where did I put it? There we go. Okay, checkout B, select samples. Boom. Alright, we are there. Let's put that in. And again, read some code here. Alright, so we have 2 channels, channel 1 and channel 2, from the example. Then for each channel, we're going to receive a value after some amount of time to stimulate blocking RPC operations. RPC being remote procedure call. Let's talk about that for a second, just in case, covering all the bases here. RPC. Oh, come on, give me the actual. There we go. Oh, good. We got a Wikipedia page. It's always good when there's a Wikipedia page. Here we go. So in distributed computing, a remote procedure call is when a computer program calls a procedure or subroutine to execute in a different address space, commonly on another computer or shared network. So this comes up a lot. You'll hear RPC. Sometimes it's a little overloaded, but usually it's primarily a technical term. Yeah, so it's definitely not a marketing term. Be thankful of that. But yeah, RPC, very commonly used, stands for Remote Procedure Call, and is generally, you're calling something that another computer is going to execute, not particularly the one that you're working on. So I'm also glad that you're here, Kathoka. I have no idea if I'm saying that right. So feel free to send me a pronunciation guide, and I'll always make every endeavor to say names right. Alright, so we're going to do a select here. We're going to look at this a little bit more in the editor. So we use select to await both of these values simultaneously, printing each one as it arrives. Alright, so we've got little timers on here. Then we got this anonymous function here going at a, oh, it's just flipped around the second here. So 1 second, and this one's at 2 seconds. So it should go 1, 2, right? It should count out. Received 1, received 2 effectively. Select to await both these values simultaneously. So here, oh, okay, so it's select. Once you receive this, do this. Once you receive that, then do that. So theoretically, we should just get 1, 2 printed out. Everything, so 4i, go through 2. Okay, so let's run that. See if it executes okay. Received 1, received 2. Alright, in 2 seconds we get all those things. Let's see, message 1, message 2. So here we pass from channel 1 to message 1, channel 2 to message 2. This is another very good way to do, basically you're doing a blocking wait for these things too, as you wait for each message. Because you have this for loop, which is, it starts with 0, and then it goes, okay, when I get 1, I can increment, right? It is what it's doing, but channel strings. 1, 2. Oh, I gotta let it follow, huh? Teinslal. Welcome to the Mosh Pit. We're just learning a little Go today. Digging through Go routines and channels and figuring out how the channels work. Kind of drawing a blank on why the for loop specifically waits. Like, why wouldn't it just step through, and if it has one of these things, print it out, and then just it's done? Why does it actually block? Is this... I don't know, I feel like I'm missing something, like why it's actually blocking and stepping through accordingly. Because yeah, if we execute this, it's definitely waiting a second to do the thing, right? It's like 1, 2, and then done. Case. So that's good to note though, that it waits when you do a select like this. So it's blocking until it's done, or it's waiting until it's done. I guess it's not blocking other execution because it's executing both of the workloads there, the 2 anonymous functions, and then it just prints out received once it receives that first one or whatever, and it goes to the next one. So like if we go to 3 seconds, what happens? Let's see about that. 2, 1. Okay, so that just waits 3 seconds. So it's almost like this is in a wait loop of its own. There's the default case. Oh, okay, okay. Yeah, I get that. Still seems a little weird to me. I wonder if like the language itself is like, I guess, do they have to write extra logic for it to perform blocking in that way, for a select statement to perform blocking? Because like we can't do this with an if statement, right? It has to be a select statement. It's important differences to note when writing Go code that I just had not thought a lot about. No cost, okay. Okay, so it's not like sitting in a loop spinning up CPU cycles or anything. It's literally like kind of just sitting waiting. Yeah, okay. It strikes me as weird. I don't know. Probably because of my context of, well, I guess it's a select statement. It's not particularly a switch statement. It's different. I don't know, I feel like I need to read about internal implementations of this stuff, specifically the select. All right, well that's cool. I mean, that's a good example. Proves out how that works exactly. Select await both these things. So await sync dot await. All right, let's get that one in there. Example of using a select to wait for completion. I'm definitely going to use that in the future. I like that one. I like that structure. And when you know what it does, it's kind of readable. I don't know. I feel like it's readable because it looks like you're just putting a checklist of things, in a to-do list, like do X, Y, Z. When X is done, and Y is done, and Z is done, then you are done. Timeouts are important for programs that connect to external resources or that otherwise need to bound execution time. Implementing timeouts in Go is easy and elegant thanks to channel and select. So this is huge. There's a lot of ideological implication of this from the perspective of what Go is actually written to do, which is to be a systems programming language that works against a bunch of machines in a distributed systems environment, etc. So it's neat that they point out how simple this is to do. One of the reasons it is simple, or simpler than one might find in other languages, is because of its intended usage. So let's implement this one. This looks pretty cool. I gotta say, all the work that they did on this Golang playground and everything is super, super, super badass. Let's get back to the terminal. And let's hear checkout -b timeout examples. There we go. Head back to reading some code. Okay, so we have one channel, and it's a string. Turns its results in channel 1 after 2 seconds. So here's our anonymous function that's executed via GoRoutine, and it just passes back result 1. Then the select. Here's the select implementing a timeout. Res1 awaits the result, and time after awaits a value to be sent after the timeout of 1 second. Since select proceeds with the first receive that's ready, we'll take the timeout case if the operation takes more than allowed 1 second. Okay. Right, so will it take more? Oh, 2 seconds, yes. So result 1, timeout 1, response. If we allow a longer timeout of 3 seconds, then the receive from C2 will succeed and we'll print the result. Okay, so 3 seconds here, and we'll print out timeout 2, but we'll get the result. So executing that with the IDE, we should get timeout 1 is triggered, but we get result 2, which is as expected, right? So here's result 2, which we got from the message channel. And then up here we did not get result 1 because it timed out, so we got hit with the timeout 1 here. That is pretty easy, I have to say. Alright. Example of waiting for completion from timeouts. I.E. getting timeouts and handling them. There we go. Non-blocking channel operations. Alright, basic sends and receives on channels are blocking. However, we can select with a default clause to implement non-blocking sends, receives, and even non-blocking multi-way selects. Alright. I mean, the obvious reason you want non-blocking things is because you want to be able to continuously do whatever while you're working, or while the code is working, your workload is working, right? Alright, so we're going to do get checkout new branch. We'll call it non-blocking channel operations example. Huge one there. So here we have two channels, messages and signals. One being a channel for bool, one being a channel type string. And then we have a select waiting. And here we have a default. So as Dave Dev mentioned a minute ago, if there's a default, it'll pop out, right? It won't wait around for things. So we'll note that in how this executes, right? Here's a non-blocking receive. If a value is available on messages, then select will take the messages case with that value. If not, it will immediately take the default case and continue onward. So it's not going to block, but if something is available for whatever reason, boom, grab it and start working with it. And here a non-blocking send works similarly. Here message cannot be sent to the messages channel because the channel has no buffer and there is no receiver. Therefore the default case is selected. Right, so here we're going to get no message sent. Here, what is it we're actually going to get? So we're looking at messages from the messages channel. And we'll say we received a message, I believe, right? No? Well, we don't really have one. We haven't received a message. And then here we can use multiple cases above the default clause to implement a multi-way non-blocking select. Here we attempt non-blocking receives on both messages and signals. And if none, then we get no activity. So let's execute, see where we get here. And of course, nothing is set. So no channels have any, they haven't received, they haven't sent, and they have no activity. So in every situation, nothing is blocked and waited for. It just executes, and boom, we can continue doing whatever we're doing. Basically, this is a great way to go through, determine things. Oh, wait, we have a message right here. Why did that not work? We got no message sent, but there's a message right here. There's nothing here. Let's run that again. It says no message sent. Oh, no message sent because, oh, okay. It's just a sign of this, but it's not put into messages, is it? Let's actually do that and see. Messages. Can I do that? Let's see what we get. Oh, I blew it up there. Deadlock. All Go routines are asleep. Of course. It's not even running a damn thing. We have no Go routines running here. So I don't even know why they... Let's see what is it. here message cannot be sent to the message channel because the channel has no buffer and there's no receiver. Right, it's not even, like a routine isn't even executed yet. So of course, it would be a deadlock, right? Not just a normal panic, but a fatal error deadlock. Slick. Alright. You know, I like Go more. The more I play with it, the more I like it. It's pretty nice. Alright. So, covering a lot of bases here today. Example of non-blocking. Get checkout / new branch. And let's look. I think we're going to wrap this one up with rammed over channels. Yeah, we're going to wrap this one up with closing channels. Maybe. Nah, we'll keep going. So let's hear closing channels example. So here, what do we got? Boom. I just noticed at the bottom here, we're waiting for something. So let's see, we'll look at this. We got two channels at the top here being assigned. Jobs, int 5, done, it's a bool. And then we actually have an anonymous function routine executing for however many jobs. Pass that into jobs receive into more J. If more, weird. So okay, yeah. And so if more, received job, received all jobs, done, true, return. Ah, interesting. Okay, this sends 3 jobs to the worker over the job channel, then closes it. And here's our close syntax. So that's how you close a channel. Here's the worker go routine. It repeatedly receives the jobs from J, jobs with J, here, more, this. And this special 2-value form of receive. Ah, okay. The more value will be false if jobs has been closed. Oh, closed. That's funny. Put a thing in there. Whatever. And all values in the channel have already been received. We use this to notify on done when we've worked all of our jobs. So this is going to assign jobs to J, and more is just false because it doesn't exist in this case, I guess. That's an interesting way to receive that. So if more will be, the more value will be false if jobs has been closed. Oh, interesting there. Interesting. So let's run that, see what we get. Sent job 1, 2, 3, sent all jobs, received jobs 1, 2, 3. That's pretty slick. So with this in the func, in the anonymous func, you can receive all the jobs, and then this is going to go through and tell you when you've got them all done, and then it's going to close jobs when it's done. And of course here, we're waiting for done. Nice. Intriguing. I'm not sure if I find that one that readable, but still a good one. So example of blocking until all jobs completed. And for me, it is time almost to go eat. But we're going to look at one more, range over channels. Previous example, we saw how for and range provide iterations. So for and range Q So this is channel string 2, 1, 2, close Q for element range Q. Oh, interesting. So let's actually put that. Yeah. Let's see here. Put that one in here. Oh, whoops. Did I? There we go. Oh, no. Yes. Closed it too fast. There we go. So it looked like, oh, yeah, I did get that one in there. So let's do git checkout. It's gonna be our last one for today. The channels, range over channels, example, clear. Let's get that one in there. All right. So here we'll iterate over the two values in the Q channel. It's closed here, but then we're going to range over them. So we should get 1, 2. The val OK form is not particularly common or uncommon. Okay, true means that image of values received in value is a useful value. Interesting. Good to note, Dave. David Dev. I'm gonna start calling you David Dev, right? Because that's how you've got your name spelled, actually. Now that I look at it, I notice you have 2 D's. David Dev. You got a .dev. That's awesome. I keep thinking about buying one, but then I procrastinate, and I also don't want to spend like $400. But I don't know. Might have to do it just cause nerd, you know. Oh, what? Did somebody follow? I just missed that. Should be. Last I looked, it's still just recently. It's still like $350. It used to be like 3,000 or some stupid nonsense. Like I'm not paying 3,000 bucks for that. I already got Adrian.me, and Adrian got some other stuff and whatever, and Adrian Bikes. I think I have Adrian.bike or something like that. Yeah. My blog is on compositecode.blog. I thought that was pretty good. I got compositecode.com too, though, but I'm like, maybe if I ever start a business, I'll use that one. Oh, let's see here. Last thing here. So how does it work? 1, 2, just like we expected, right? That one's, I don't know, that one looks pretty self-explanatory. Anything of note from this one, David Ev? I mean, it's just going over the range. Straightforward thing to use. Once familiar with the channels, so doesn't seem crazy or anything. I do find it interesting that channels are used so often in conjunction with Go routines, but these examples are purely just the channels. But I guess you could use them for all sorts of stuff. That's cool. I'm going to commit this now. Example of elements of range of channel. Now I need to go through. Yeah, event log. Thanks for all that. Clear. Let's exit out of this, and I'm just going to open up the terminal and do some of this stuff. Let's make sure that I've actually put every one of these things in there. So Adrian, learning, go, episode 7. There we go. Those 2. Oops, source, GitHub, Adrian, clear list, speed, learning, go, episode 7, git, branch. Alright, we'll git push, origin, so we get channel, directions. Do that just so I can back to it again. There we go. And channel synchronization example. And closing channels example. And go. I got that go routine channels example. Whoops, I already ran out of space here. Git branch again, please. What else I need to add? Non-channel operations example. And git push origin, closing, closing, no, closing, did I just do that one? I got myself out of sync here. Channels, example, whatever, git push origin, select examples, and then git push origin, timeout examples. Yeah. Alright, so git branch. Now git push origin range over channels example. Alright, git branch. So we have basic go, channel directions, channel synchronization example, closing channels example, go routine channel examples, master of course. Don't have non-blocking. Okay, but we got range, select, timeout. Okay, git push origin, non-blocking channel operations example. And ta-da! That's it. Alright, so at this point, let's figure out the super important situation of who shall we raid, right? Raiding, that's always an important thing to do. So, who do we want to raid, y'all? See anybody out there in the internets? see no live channels at the moment. So I got a big shout out to Ashley McNamara. I pinged her and said, "Yo, I need a death metal gopher. What do I do? And she hooked me up with a death metal gopher. So, oh my god, there's nobody that's streaming? That's gotta be nonsense. Oh, Dev Chatter is streaming. Robert Tables is streaming. Amirjan's streaming. Dan, the developer. What is everybody working on? That's the real question, right? So, who do we raid, y'all? Come on. It's got to be somebody that we want to raid. I'm peeking at Robert Tables real quick. Carrie just said she made the stream. So let's raid Robert Tables again. Let's see here. Oh, now my stupid form pops up right. It threw an error a minute ago. It says he's please standing by, but we're gonna raid him anyway because I'm sure he'll be back in just a minute. Come on, it's got to be at least 2 of us. Yes, 3 of us. All right, sweet. Raid now. Here we go. Thanks for watching today, everybody.